So we're going to now look at partial fraction decomposition, or the start of partial fraction decomposition. So we're going to look at taking a complicated fraction and rewrite it as a sum or difference of multiple fractions. And so this is a very useful technique when you get into calculus, especially calculus 2, when you get into integration. And actually, this could be helpful for differentiation too. But let's get into what we're going to be doing here. And so partial fraction decomposition, you're going to have some fraction where you have a polynomial, let's say p, divided by some polynomial q. Let's say that q, remember we could take a polynomial, we can break it down as a product of linear factors and or non-reducible quadratic factors. And so let's say in this case, q can be factored as a product of linear factors or non-repeating. So a product of non-repeating linear factors. So we're going to look at different cases. If you can factor it and one of those factors is linear, but it's repeating itself, then we're going to be doing this a different way. Or if we factor our denominator and we get a irreducible quadratic factor, we're going to have to rewrite our fractions. But first case scenario, q can be factored as a product of non-repeating linear factors. And so if this is the case, then we're going to take this p over q and we're going to rewrite it where we take some variable and we're going to, let's call it capital A, and we're going to put it over one of our factors. So let's maybe say a sub 1 times x. I don't know, plus a sub 2. Plus, let's say we have another factor, a linear factor. And so we would take our next factor, we would say, okay, capital B all over whatever that linear factor is, b sub 1 x plus b sub 2. And we would continue to do that. So let's say that q, that factor in the denominator was what we just said, a sub 1 x times a sub 2, b sub 1 x times plus b sub 2, and dot, 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 depending on how many linear factors we have, plus the last linear factor. And let's just call it capital C in the numerator, but the linear factor in the denominator, c sub 1 x plus c sub 2. So let's look at a case scenario where we're rewriting our fraction using these partial fraction decomposition. So let's say we have this fraction. We have x in our numerator all over x squared minus 5x plus 6. So first step, is factor your denominator. And if our degree of our numerator is the same or larger, we're going to actually want to do long division. In this case, it's not. So first step, factor your denominator. So doing so, we have x all over. In this case, I notice that x squared minus 5x plus 6 can be factored as x minus 2 all times x minus 3. So now let's rewrite this. as a sum of rational expressions. And so what we just have, this x all over x minus 2, x minus 3. Both of these are linear factors and they're not repeating. So capital A all over x minus 2 plus capital B all over the next factor, which in this case is x minus 3. So once you've done this and you split it up as a sum of rational expressions, then we can clear our fractions by multiplying both sides of our equation by our LCD, or least common denominator. Okay, so doing so, I'm going to multiply both sides of this equation by x minus 2 all times x minus 3. It's always going to be how you factored that denominator. X minus 2 all times x minus 3. So notice when we multiply it on this left-hand side, we're just left with our numerator, x. This is equal to, so if I distribute, and we need to distribute to each fraction on the right-hand side, when we distribute to that a all over x minus 2, the x minus 2's are going to cancel, and you're going to be left with a all times x minus 3. Plus, and so when we distribute x minus 2 all times x minus 3 to the fraction b over x minus 3, x minus 3's cancel, and we're left with capital B all times x minus 2. So looking at this, let's distribute our capital A to inside that first fraction, or not fraction, parentheses, and capital B inside that second parentheses. And so doing so, we get x is equal to capital A times x minus 3 times capital A plus capital B times x minus 2 times capital B. So notice that we have two terms with x in it on the right-hand side and just one term with x on the left-hand side. So technically, when I sum this ax plus bx, it needs to equal 1x. And so we can say here that 1, that coefficient in front of x, which is 1, has to equal the sum of capital A plus b. So notice we have constants here. Capital A and capital B are just some number. And notice that this left-hand side doesn't have a constant. So we can think of it as 0 plus this. And so our constant of 0 on the left-hand side, which is 0, has to equal the sum of the constants on the right-hand side, which in this case is negative 3a minus 2b. So notice here we have a system of equations. We have two equations, two unknowns. And so we want to solve that system of equations for capital A and capital B. And if we do so, then we have the sum of simpler fractions that would give us our original expression. So you can use matrices here if you would like to solve, or we can use elimination and substitution method. Let's quickly use matrices just because we just learned how to use matrices. And so I'm going to write it where I have A, the coefficients in front of A on one side and my numbers on the other side. So coefficients, first row would be 1, then 1, and then my number is 1. Let's go. Coefficients for my equation would be -3, -2, and 0. So I have a 1 where I want it, that first row, first column. I'm going to use that 1, that first row, to manipulate row 2 and get a 0 where that -3 is in row 2, column 1. And so I know that if I look at 3, row 2 could equal 3 times row 1 plus row 2. So row 1 is 1, 1, 1. Row 2 is now going to become, well, 3 times 1 is 3, minus 3 is 0. 3 times 1 is 3, minus 2 is 1. 3 times 1 is 3, plus 0 is 3. So technically, I could read off from this matrix, augmented matrix, that last row, that's my B. I have 1B equals 3. So I know what B is. That first row, I have capital A plus B equals 1. So if we plug in 3 for our B, we could solve for A. So we can not go through and rewrite this totally in reduced echelon form to solve. So I have A plus 3 is equal to 1. So I have A here, 1 minus 3, so is -2. So we just manipulated this fraction, x all over x squared minus 5x plus 6, as the sum of A. So A here was -2, all over the factor of x minus 2, plus my B, but we found B was 3, all over x minus 3. So we only had a chance to look at one case scenario and just one example of that case, but you can get a flavor of what we're going to be doing as we go through and lecture more on these partial fraction decompositions.